Hello students, today we will be dealing with surface tension in greater details. Here we will be looking into how the surface tension can be expressed in various other ways. Then we will go to the topic of surface energy. So let's start the topic. Now an equivalent definition is the work done per unit area. This definition is again for the same quantity surface tension. As such, in order to increase the surface area, quantity of work is needed. This work is stored as the potential energy. Now since the mechanical systems try to find a state of minimum potential energy, a free droplet of liquid naturally assumes a spherical shape which has the minimum surface area for a given volume. As we have seen that due to the surface tension, any surface tends to have a minimum surface area. It tends to have a minimum surface area. Now since the sphere, it has the minimum surface area for a given volume, that's why the liquid tries to assume a spherical shape. Because for a particular volume, a sphere has the minimum surface area, that's why it tends to assume this surface area and become a sphere. Now the definition is the work done per unit area. Now if you take the case that we have done in the last slide of a soap film being pulled through a thread, this is the thread like this. Now if you pull it this, what happens? A new surface area is being created. This is the surface area that is being created. Now this surface area is created by doing the work. Now this work is force F dot dx. If you move this distance by a dx, this is F dot dx, means if you are pulling this with a force F and we pull it by dx, we do a work dx, F dx on it. Now this increased surface area, now this surface area is increased, that I have shaded now. Now this increased surface area, the quantity of work is stored as potential energy. This is stored as potential energy. Whatever work has been done by us is being stored in this as potential energy. Now what is the work done? F dot dx. Now we have seen what is the force. It's 2 sigma L into dx, that is needed to maintain it equilibrium, and we are moving it very slowly so that the change in kinetic energy is 0. So whatever work is being done, it goes into and is being stored as the potential energy. So work done, now this can be written as sigma dot dA, where dA is the area created. Now if you see, the area that is created is not only L into dx, but it is L into dx from the top surface, and then there is another L into dx that has been created from that side, from the bottom surface. Two surface areas have been created. So the total surface area created is 2 times L into dx. Now this 2L dx has been written as dA. This is the area that has been created. So the surface tension sigma is defined as the work done in creating a surface area dA according to this definition, and it is said that this is the work done per unit area is called the sigma. Now let's solve some questions. Now the question here is, the surface tension of a liquid is 5 Newton per meter, sigma is given to you. If a thin film is formed on a loop of area this, then its surface energy will be. Now there is a thin film. Now this film could be, you can consider film over this spindle shape where the liquid is there, or you can consider a spherical film on which there is a soap film. So you can consider any situation. Now this thin film, this has area, the area that is given is 0.02 meter square. What will be the surface energy of this? Now we know that the work done is sigma times dA. Now this work done is being stored as the surface energy. This work done actually becomes the surface energy. Now if you see here, the question asks what will be the surface energy. The surface energy will be the surface tension into the area created. Now what is the area created when this is actually a thin film that is formed on a loop? Now the loop could be this, loop could be this, loop could be a square loop, loop could be a rectangular loop, it could be any loop. But since this is a loop, it has two surfaces, one from the top that you see and one from the other side that you cannot see from while facing the front. It's because any film, it will have a finite thickness. A finite thickness means there is one surface above and one surface below. So the total area that has been created is twice of 0.02. So the value that we have is 10 into 0.02, that is 0.2 joule. 0.2 joule, if you look for the answer, this is the correct answer. It's 2 into 10 to the power minus 1 joule. Let's see another question. Now a disc of paper of radius r has a hole of radius r. So it's like this. Suppose this is a disc. This has a radius capital R. Now this has a hole of a small radius r. This is a hole, this is of a small radius r. It is floating in a liquid of surface tension T. Okay, so this whole thing is kept in a liquid. Now this is the liquid surface that I have drawn like a rectangular box. This is a liquid of surface tension. Okay, it is given as T. The force of surface tension on the disc is, the question being asked is, what is the force of surface tension on the disc? Now we know that the surface tension acts where the surface has opening to the surrounding or the air, because on the surface of the liquid there is a net unbalanced force that gives the surface tension. So if you try to see here, what are the open surfaces that are in contact? Now if you see, this is the surface, this surface is in contact with the liquid, and then there is this surface that is also in contact with the liquid. Now if you see, what is the length of this surface? The length of this surface is 2 pi r, and the length of this surface is 2 pi capital R. Now along this length as well as this length there will be a force of surface tension. Now as we know, this is a film. It is again in a liquid of surface tension T, it has been kept. So there are actually two surfaces, the surface that you see from the top from here, and then there is a surface from behind. So there are two surfaces that are acting at the same time. So what is the surface tension? Force is, we know, is sigma into L. Sigma into L. What is the total length? Is twice of 2 pi r plus twice of 2 pi r. So what we have is 4 times, if we take, it's 4 pi sigma r plus r. So the correct answer here is the C. So we always have to look at the surfaces in contact where the surface tension may act. So as we can see, it is this surface where the surface tension can act, this this circular surface, and then there is this circular surface. So we have to find out the net length, and then we got the surface area. So students, we saw what exactly is surface tension, how it manifests in various forms, and we have seen how it gives us the surface energy. Now in the next topic we are going to deal with capillarity and the factors that are associated with it. So stay tuned with Ask IITians for the next topic.